My name is Harneet. Thank you so much again for joining. I'm from the marketing team at Ecopia AI. We're excited to host this live event on an important topic about vulnerable road users and how the right geospatial data and other tools can help you in making communities safer. As many of you know, in the US specifically, the last decade has been marked by a troubling increase in the number and rate of pedestrian fatalities. As per the National Highway Traffic Safety Administration, there were 7,388 pedestrian fatalities on US roads in 2021. There was the highest number observed in 40 years. All of you, the stakeholders in this process, the transportation planners, the regional associations, the city government, the state and federal agencies, everybody has an important role to play, and geospatial data can help you make those right decisions when you have something which is your source of truth to make those decisions on. There's a lot of location-based data services available out there, but there are obviously gaps, as we would find out today, when it comes to speed, comprehensiveness, freshness of data, and other attributes. It is important that you have the right data before you make those important decisions, which can save lives and improve communities. To talk about the latest and real-world examples of how data can help make communities safer and better, we have someone from Ecopia's public sector team who has been really on the side of planning, so a lot of your shoes, and he has been dealing with such kind of data. So Troy Simpson is our presenter today. Hi, Troy. Troy is an urban planner with experience managing federal programs and performance measures for surface transportation, serving to further Ecopia's impact in this space. Troy began his career at the University of North Carolina at Chapel Hill, where he studied GIS as well as urban and regional planning. While working for the Chicago Metropolitan Agency for Planning, CMAP, he leveraged prior experience with travel models and GIS workflows to develop objective ranking criteria to reduce political influence in project selection, as well as high-quality active transportation networks to ensure consideration and improvement for all modes of transportation. Troy enjoys living in the Great Lakes region and can be found exploring them by bicycle, even in the winter season. So let's start with Troy. Kick off the webinar. Over to you.
Sure. So just to give a rundown of how things are going to go, I'm going to give a quick introduction to the types of data that we're producing, that we're talking about, as well as on Ecopia AI. And then we'll kick off into basically the area that I chose for the study that I'm going to show you all is based in the Baltimore region. So it's a 700 square mile region that constitutes basically what the Baltimore MPO is designated to plan for. And then we'll have a little bit of a Q&A session, time permitting, hopefully a good quality one. So just an idea of what Ecopia does. We are a company that's pretty much solely focused on extracting value from aerial imagery. So a lot of the high resolution aerial imagery products that are available at the state and regional level now, we pull out certain criteria, basically using machine learning, deep learning methods. So we do this in a series of different data sets. The ones that are most pertinent to regional and state planning would be your linear networks, 3D structures, and land cover. And those are basically things that are a part of our entire mission to develop a digital twin that can be queried for a number of uses. So this could be based on insurance, risk, environmental resilience, as well as in this case, understanding transportation equity, particularly in the realm of vulnerable users, because often a lot of regions don't have access to a comprehensive data set that they can even use to measure what the impacts to vulnerable road users are. And so we've performed this work for quite a number of regions at different scales, as well as at the state level now, or across the United States. So and actually, one of the highlights that I'm most proud of is that we actually did some digging into our past data, and we have done the first region-wide sidewalk crosswalk network for now 26 metropolitan planning organizations across the US, including San Francisco, Chicago, and Baltimore. So for the Focus for Vulnerable Road Users analyses today, I'm going to run you through a couple of processes based on some of the work that I used to do that is essentially trying to funnel down ultimately what constitutes an underserved area in the context of the transportation networks that vulnerable road users might use. And for that context too, for those that may not be as familiar with what a vulnerable road user is, it could be defined as someone who is a pedestrian, it could be older age, it could be a cyclist, it could be anyone who's using the transportation network in a non-single occupancy vehicle capacity. So transit users are also a part of this. And there's a multitude of risks. You could define vulnerable road users in a lot of ways, but there is a standard Federal Highway Administration definition for that. So this data set here you can see is one that we performed for the Baltimore Regional Transportation Board. They are, as I said, one of the MPOs that got their first region-wide sidewalk network from us. It was extracted off of near-map 6-inch aerial imagery, and it provides a width attribute of sidewalk layers. So this is really a never-before-seen lens into mobility in the region that can take into account mobility device users. And some of the data that we're also using in this analysis comes from the Maryland DOT. So there's data that they have available on the lane miles, as well as other characteristics of their roadway network that we've used to overlay and come up with safety hotspots and other analyses. And so with our sidewalk layer, as I mentioned, you can understand, basically benchmark measures on the pedestrian environment for the entire region, not just in some cases where you have maybe the main city as well as a couple of superstar suburbs that have really, really good quality networks available to them in GIS layers. And it allows them to actually measure the impacts of potential projects on pedestrian mobility and accessibility and do some scenario planning as they're engaging in that. So running into some of the analyses off of the sidewalk network, what we're looking at in this series of maps here, basically we're going to funnel down into areas that concentrate on, basically areas with a high potential of vulnerable road user populations, as well as the quality of the network relative to the environment that they're in. So what you're looking at here is basically an overlay of the US Census data from the Census API with basically a measure of the proportion of the pedestrian network to the roadway network. So how much basically pedestrian access route mileage, essentially marked crosswalks and sidewalks, is there relative to the roadway mileage within each census tract. So this first map looks at it just from a raw standpoint. So, predictably follows the trend of urban, suburban, and rural densities coming out from the center. It doesn't really give us too much of a picture of where we need to concentrate our funds, where we need to concentrate our efforts. If you take that and normalize it by population, it ultimately follows the same trend, but you start to see a few disparities basically within the city. You normalize then by population and income, because income positively correlates with the tendency to use a vehicle, and then you're beginning to see potentially underserved areas. In terms of the US Census data, you can also normalize this by households without access to a vehicle, which provides perhaps an even better measure of that. But a note when you're using measures like this, if you're performing such an analysis, is that not all no-car households have low income, particularly in downtown cores in the US. So it's always important to use a multivariate system when you're trying to identify potentially underserved areas that you would like to mark or like to focus on. But in this case, between those two, between looking at it from a standpoint of income, as well as basically the characteristics of car ownership, you really begin to see basically a spatial trend. It tends to be in a lot of the ones that I've done for this webinar, you start to see a focus on the outer neighborhoods of the city as well as some of the inner suburbs. It's important to look at that from a regional standpoint because vulnerable road users who are potentially underserved don't necessarily always inhabit inner cities alone, and that really varies by region as well. So the next layer that we produced for them is, as I mentioned, we had basically had topologically connected crosswalks into the network. What that means is that basically it's a routable network. So you could, for example, say, I want to produce an access map of, basically from, say, schools. And, you might want to say how many locations will a child have to cross at an unmarked location, say on a 4-lane plus highway or a highway with a certain level of traffic. The way we classify our crosswalks in this case are continental, ladder, standard, and unmarked, as well as other. Usually others, not a really large category, it's just unstandard markings. But it's important to have the unmarked crosswalks at the intersection polygons that we create because you can pull another layer of analysis in, but it also allows the network to be more routable. But what these classes enable us to do in terms of this analysis is to analyze high visibility versus low visibility crosswalk locations. particularly important in terms of nighttime visibility, as well as understanding risks at various intersections. So, and I say nighttime visibility for the high visibility crosswalks because in 2021, per the NHTSA, 77% of pedestrian crashes in the US occurred at night. So what you're seeing here now is a map, basically just a raw map per census tract of the percentage of total crosswalk mileage identified as high visibility. So anything that's in red is an area that basically has a large number of total crosswalks, but a low percentage of them are actually high visibility. If you normalize that by population, there's a much less clear trend in the particular case of this. It would almost technically appear to identify suburban inequities if you're looking at it as an MPO. You get into normalizing by population and income, then you start to see a more familiar map. So you're starting to see some concentrations of underserved areas, basically the same, if pretty close to the pedestrian routes analysis, some outlying rural as well as outer urban neighborhoods and inner suburbs. And then if you normalize that again by households without access to a vehicle, again, relatively familiar census tracts. Funny enough, there's a correlation between tracts that have a low percentage of sidewalk coverage relative to the roadway network, as well as ones that have high quality, high visibility crossings. And then this one we also normalized by population living with ambulatory and or visual disabilities. And then in that, you're starting to see some concentrations of underserved areas seen in the same pedestrian routes analysis, although within the city and in some of the rural areas, you see an even more concentrated value. So, a higher potential for an underserved area. Then if you take that and normalize it by populations living with ambulatory and disability or ambulatory and visual disabilities, as well as by income, this is controlling for the fact that if you are understanding vulnerable road users within a census tract, you might want to understand where there's a potential that that person is more likely to be a pedestrian or to be a transit user, in terms of if you want to increase the quality of the active transportation network or safety features within that region. It's important to look at it from a standpoint of income too, because there are different characteristics that might apply to make someone a vulnerable road user. But again, you start to see some familiar patterns from the prior spatial analyses. And then looking at the crosswalks themselves in terms of locations, this map actually displays the high visibility crosswalks only, which unfortunately are a relatively low concentration of the total crosswalks in the region. And this is actually displayed by length. So not just by counts of crosswalks, but by the total length, the exposure that the pedestrian would actually have in the right of way. And essentially anything that you see highlighted in red is a location that has, it's a high visibility crosswalk marking, so that's good. But ultimately there's a really long length of pedestrian exposure relative to the amount of traffic that goes through the roadway. So you have basically a high AADT, high average annual daily traffic roadway with a long length of pedestrian exposure. And so in this one, you see a lot of the suburban arterial locations come up, because obviously if you're controlling by length, a lot of the downtown crossings, even though they do have a high average annual daily traffic, there's less pedestrian exposure to that traffic, which is a good thing in terms of analysis, because ultimately the traffic speeds, especially during peak hours, are going to be lower, but could get a lot more nuanced than that, but time permitting. So this is that same analysis conducted for standard crosswalks. And in this, you start to see a clearer trend along principal regional arterials. And these standard crosswalks would be ones that, for example, don't have any kind of a vertically visible marking. So they might just have two, basically most of the time would just be two standard painted lines, edge to edge, which don't really provide much of a benefit in terms of driver visibility. In fact, driver visibility is increased very significantly by high visibility crosswalks. And this is something that's ultimately a useful input to predictive tools for state vulnerable road user assessments, in particular now, because upgrading to a high visibility crosswalk is a relatively low cost improvement that adds quite a number of seconds to the driver reaction time when traveling along a high speed route. Now that same analysis, comes along, for unmarked crossings, and you start to see, unfortunately, that same trend along the suburban and principal regional arterials. But in this analysis, one thing that was kind of interesting that showed up is there's a relatively high number of unmarked crossings at locations where you basically have very high volume, high speed roads that funnel into a conflict area, essentially where there's much more urban density. And one pattern that I picked up in here is that these areas are ultimately tended to be high employment industrial and commercial areas. So areas that have a low potential for remote work, people that might still be accessing their jobs via transit, and they are areas with transit access. So pretty low quality environment relative to the services that are available and the employment options that are available and the type of employment. And going back to the sidewalks, I'm going to analyze these from a disability perspective, because disabilities should not be, people living with disabilities should not be excluded from a vulnerable road user analysis. They ultimately are vulnerable road users. Nearly half of pedestrian collisions within intersections are people using a mobility device. So it's not to be understated as an important metric. So this ultimately is just a raw map of basically within that census tract, the percentage of ADA width compliant sidewalk versus the total sidewalk network within that census tract. Anything ultimately within, say, like a bright red spot would be an area where basically the ADA compliant width network represents a pretty small share of the total sidewalk network. If you take that and you normalize by population again, ultimately follows the same trend, but it does temper some areas with very little pedestrian infrastructure and low population, but ultimately still a little bit of a messy analysis, not a very good metric, not very equitable. You normalize that by population and income, starting to see more familiar trends going to the inner suburbs, outer neighborhoods of the city again. And so, these are areas that, basically show a potential spatial mismatch between roadway users and their environs. But that doesn't account for necessarily people that are living with disabilities. So if you take that map and you normalize it by the population living with an ambulatory disability, most likely populations to use a mobility device, you end up with a relatively high rate of dispersion, but you still see some of the same populations within outer neighborhoods of the city, inner suburbs. Interestingly enough, though, if we run the same normalization for income, so those with ambulatory disabilities that are more likely to be regular transit users and pedestrians, you really start to see the full concentration that has been, reiterated in the past series of maps, that you really do have some low-hanging fruit when it comes to areas that could be significantly improved in terms of access to accessible infrastructure for people with mobility devices. And this is ultimately important because in order to prevent, say if we wanted to look at users of mobility devices as a portion of vulnerable road users within a region in that definition, and we want to improve the environment for them, we would want to understand how many route options do they have from one area to the next, because that has an impact when you're looking at how people move throughout and how they route through a network. That has an impact on how often and for how long people who are using mobility devices are exposed to mid-block crossings, to intersections where they have a potential vehicle conflict or a site conflict. So it's not to be understated that understanding how often is there a potential that someone in a mobility device might have to cross the street because the sidewalk on one side is not in a good enough condition or does not match the width necessary for their mobility device. That has a significant impact for those types of users. And another characteristic, interestingly enough, that we were able to collect off of the 6-inch imagery is detectable warning pads. So a lot of you might be familiar with the detectable warning pads at curb ramps. So usually either bright yellow or some kind of a contrasted color, perhaps can even be metal. These are basically for people with visual impairments to recognize areas where they might be coming into traffic. So relatively predictable. This is kind of understood widely that ultimately, the concentration of these types of curb ramps, so anything that's in yellow is ultimately a curb ramp that has this ADA type. So this would have like a detectable warning pad. Those are concentrated along the principal roadway network. And then you see basically some clusters in outer neighborhood developments. So these are going to be like more newly developed areas that are following the ADA standards that have basically changed through the years. So nothing really incredible there, but at least you see sort of a proportion of the roadway network that has those available. Now, if you take that and you map it out to the census tracts, you see ultimately, few major outliers. There's not really anything particularly amazing going on with this map. So this is the number of ADA type curb ramps versus the total number of curb ramps within each census tract. If you normalize it by population, you see some downtown core and areas with larger, newer developments showing a positive trend, just as we saw in the last. And if you normalize it by population and income, you start to see some of the outer neighborhoods of the city, though the trend is not nearly as strong as the trend was with sidewalks and crosswalks in the same analysis. I had a hunch potentially that this could be due to federal requirements to upgrade infrastructure to ADA standards when performing resurfacings on federal aid roads, because there was a relatively high percentage of those type of curb ramps available along the principal routes. So those tend to be spread region-wide and might kind of temper the inequities a bit. If you normalize it by the population living with a visible or a visual disability, it's relatively dispersed outside of the city in this example. A low sample size, unfortunately, hampers this. So low sample size of persons with visible disabilities versus ambulatory. But ultimately, if you normalize by the population living with a visual disability as well as by income, you get back to the same concentration more or less, even with the smaller sample size. So the same neighborhoods tend to pop up as potentially underserved areas and follow more or less the trends that we would expect. So in these analyses, hope they were relatively useful to look at or to understand. Some of the takeaways that I have from it and from my prior work and from where I see these things going is I think we're at a spot where the intersection of standardized geospatial data, that being on a regional scale on the active transportation environment, robust demographic data, which we've had for some time now, although it's improving, location-based services and other ITS sources are paving the way for an equitable predictive safety analysis. So this means to me in an environment where there is a lack of quality collision data, there's a lot of unreported collision data with regards to vulnerable road user types, and in an environment where we don't necessarily diligently count bicyclists and pedestrians as users in the roadway network the same way that we do for single occupancy vehicles and transit vehicles. This ultimately, a combination of these services can help us still target areas predictively where basically vulnerable road users are facing the highest risk, and also to calculate out where is the system that they're using the most comfortable and the most appropriate, and are we allocating resources efficiently to those who need it most in their various regions. So I think that this is all leading to a much better standard practice for the industry, predictive safety analysis procedure as things get taken up. So another takeaway is that regions and states serving as data hubs for their local partners promote data equity across communities of all capacities. This in the context of the Baltimore region would mean, as I was saying earlier, you might have a lot of good active transportation network data for the principal city, as well as a few perhaps well-resourced suburbs that have excellent GIS staffs, even community volunteers to map out that data in various regions. But ultimately, if a region is serving as a data hub, or at the state level, if they're serving as a data hub, they have a strong potential to reduce inequities between communities. So unfortunately, a lot of vulnerable road users tend to live in communities, particularly if they're outside of the principal city. They tend to live in communities that have a much lower capacity to produce these kinds of data so that they can even be measured to begin with. So this helps to temper the inequities that are caused by a lack of good pedestrian data. And last takeaway is you can't fully measure the equity and safety impacts of transportation decisions to vulnerable road users if you don't understand the systems they use. I ran into this problem in my prior position, and a lot of my work was to create the underlying data to even analyze the active transportation network to begin with, because we couldn't develop any performance measures that were defensible or that could be voted on by committee if we didn't have the evidence-based approach.
Awesome. Thank you so much, Troy, for all those insights. I hope all the data you shared was valuable to everyone who joined.